Here we have a pre-calculus question. Okay, let's go with the question. The graph of y equals to tan of 1 over 4 times x negative pi over 2 positive 1 is shown. What is the period of the function? Where are the asymptotes of the function? What are the x-intercepts of the function? Okay, here we have tan function. Its function is given over here. So for our first work is to find the period of the function. Usually we consider the basic tan function, that is y equals to tan x. So the period of a basic tan function is just y. So because that means that we have one period, like we have multiple patterns for this basic tan function. So we have one, but the period of one particular pattern is just y. So this is a period for a basic tan function. But our first question is to find the period of the given tan function. So to get the period of the given tan function, what I need to do is I have to divide the period of the basic tan function phi by the value which is multiplied over here, that is 1 over 4. Pi divided by 1 over 4. Okay, so we can write this pi as it is, and we can change the division as multiplication, and we can take reciprocal of this number. The reciprocal of 1 over 4 is just 4 over 1. So pi times 4 is 4 pi, and the denominator 1 can be ignored. So the period of the given tangent function is 4 pi. So this is the answer for the first question. Okay, now let's do the second question. Okay, the second question is, what are the asymptotes of the function? Okay, so we'll have multiple patterns for all tangent functions. So for this tangent functions also, we'll have multiple patterns. So for this pattern, this is one of the asymptote, and this is one of the asymptote, I mean the vertical asymptote. Usually we'll not have horizontal asymptotes for a tan function. We'll have vertical asymptotes. We'll have multiple vertical asymptotes because we have multiple patterns. Here we have a pattern, here we have a pattern, here the pattern continues. Okay, so we'll be getting multiple asymptotes. So how do you have to find the equation of the asymptotes? See, whenever we have a function, whether it's a tan function or whatever function it is, for example, if I have a function y is equal to f of x in general, and if I want to find the equation of vertical asymptotes for this function, so what I need to do is I have to find the value of x for which y becomes undefined. So for example, let's consider a finite value a. So when x is equal to a, y equals to infinity, that is y becomes undefined, then the x equals to a represents a vertical equation of the vertical asymptote. So because when x equals to a, y becomes undefined, so we have to find the value of x for which the value of y, I mean the y becomes undefined. So then the value of x represents the vertical asymptote. Okay, so here let's consider the basic tan function, which is y is equal to tan x. Okay, so how do we have to find a vertical asymptote for this one? We will not have a horizontal asymptote for a tangent function. So asymptote means we have to find the vertical asymptotes only. Okay, so what value should I plug in for x over here so that the value of y, I mean the value of tan x becomes undefined? So already we know that very well, when x is equal to pi over 2, that is for 90 degree. So what will happen over here? We will be getting y is equal to tan pi over 2. What is the value of tan pi over 2? It's undefined. So when I plug in x equals to pi over 2, y becomes undefined. So for this basic tan function, this is the vertical asymptote. Okay, the same logic we have to apply in our problem. So let's consider the given tangent function. So at the place over here, if I have pi over 2, so what will happen to this value of tan? It will become undefined. Undefined when we are, even when we add 1 to the undefined value, it will still be undefined. So at the place of here, if I have pi over 2, then it will become tan pi over 2, it will become undefined. I mean the value of y becomes undefined. So if I want to get that vertical asymptotes for this tangent function, so I must have pi over 2 at the place over here. That means the value of 1 over 4 times x negative pi over 2 must be equal to pi over 2. Okay, now we have to solve for x to get the equation of the vertical asymptote. For that, first we have to get this 1 over 4. That means particularly we have to get this denominator 4. For that, I have to multiply both numerator and denominator by 4. This 4 will cancel out. I'm just getting 1 times x negative pi over 2 equals to 2 goes into 2 1 times, 2 goes into 4 twice. I'm just getting 2 pi. Okay, now let me add pi over 2 to both sides to solve for x. Okay, so here negative pi over 2, positive pi over 2 will cancel out. I'm getting 2 pi positive pi over 2. So here let's assume this is integer. We are adding an integer and a fraction. Whenever I'm adding an integer and a fraction, So what I need to do is I have to multiply this integer part by the denominator of the fraction. Once I'm done with this multiplication, I can take this 2 as a common denominator. So 2 pi times 2 will become 4 pi. So I'm done with the multiplication, 4 pi positive pi. Now we can take this 2 as a common denominator. X equals to 5 pi over 2. Okay, so one of the vertical asymptotes for the given tangent functions is 5 pi over 2. So, but they are asking us to find what are the asymptotes. They mentioned in plural form. That is, how do we have to find the other vertical asymptotes? Okay, let me mark this value 5 pi over 2 on a number line. Okay, so here we have one asymptote. So then we'll have multiple asymptotes like this on the left side of this pi over 2 and the right side of 5 pi over 2. Okay, to get the first asymptote to the left side of this pi over 2, what I need to do is I have to add 4 pi to this 5 pi over 2. So why, sorry, not pi, 4 pi. I have to add 4 pi to this 5 pi over 2 because already we got the period of this function, that is 4 pi. So we got the first vertical asymptote at x equals to 5 pi over 2. To get the next vertical asymptote to the right of this 5 pi over 2, you just have to add the period to this one. Again, if I want to get the, after the first vertical asymptote to the right of this one, if I want to get another vertical asymptote, again I have to add 4 pi. So at every 4 pi interval, we'll have a vertical asymptote. And also we can get the vertical asymptote to the left of this 4 pi over 2. So in that case, we have to subtract 4 pi from this 5 pi over 2. So anyway, so what we need to do is to get the multiple asymptotes, what we need to do is, so here 4 pi, that means we have to add the multiples of 4 pi to this 5 pi over 2. So in general, what we will write is, so 4n pi, so where n is an integer. So for example, if I plug in n is equal to, since n is an integer, if I plug in n is equal to 0, this part will completely become 0. That is when n is equal to 0, I am getting x equals to 5 pi over 2. This is one of the vertical asymptotes. That's what we got it already. And what if n is equal to negative 1? So I have to plug in n is equal to negative 1 and it will become what? X is equal to 5 pi over 2 negative. Because when I plug in n is equal to negative 1, this positive times negative will become negative 4 pi. And this is the equation of the other vertical asymptote, I mean the first vertical asymptote to the left of this 5 pi over 2. What if n is equal to 1, positive 1? So I am getting x equals to 5 pi over 2. When I plug in n is equal to positive 1 over here, so positive 4 times 1 is 4, 4 pi. So this is the first vertical asymptote to the right of this 5 pi over 2. So these are the equations of vertical asymptotes of the given tangent functions. That is x equals to 5 pi over 2 positive 4n pi. Okay, now let's do the third question. Okay, the third question is what are the x-intercepts of the function? Okay, let me take the given tangent function y is equal to tangent of 1 over 4 times x negative pi over 2 positive 1. Okay, so here we have y on the left side. To find the x-intercepts, better we can write this y on the right side. That is tangent of 1 over 4 times x negative pi over 2 positive 1 equals to y. Okay, whenever I want to find x-intercept of a function, I have to plug in y equals to 0. So because x-intercept means where the graph cuts x-axis. At the point the graph intersects x-axis, always the y-coordinate will be 0. So that's why we have to plug in y equals to 0 into the given function to get the x-intercept. I mean the x-coordinate at the point, the x-coordinate at where the graph intersects x-axis. Okay, anyways, so now we have to plug in 0 for y into this function. So let's do it. Tan 1 over 4 times x negative pi over 2 positive 1 equals to, now I have plugged in I just plug in 0 for y. Okay, so now we have to solve for x into this one. For that I subtract 1 from both sides. So this positive negative 1 will cancel out. I'm getting tan 1 over 4 times x negative pi over 2 equals to negative 1. Okay, so if I move this tan to the other side, because my aim is to get the value of x, so for that I have to isolate x. If I move this tan to other side, it will become r10 or tan inverse. That means 1 over 4 times x negative pi over 2 negative, tan inverse of or r tan inverse of negative, tan inverse or r tan. Okay, so now we have to get the angle measure which is equal to tan inverse of negative 1. Already we know that in the first quarter, usually we start finding the value. Whenever we want to get angle measure for inverse trigonometric functions, I will start finding the angle measure from 0. Okay, so in the first quadrant, so we definitely will not be getting angle measure which is equal to this one in the first quadrant, because here we have a negative value for tangent. So negative value for tangent means, because in for all the angle measures in the first quadrant, all trigonometric ratios are positive. So, but here the value we have for this tangent function is negative. So definitely will not have the angle measure in the first quadrant. Anyways, let's assume this negative one as positive one. In case if you have positive one, then we'll have the angle measure in the first quadrant. So what angle measure will be getting? The value of tangent function is 1. So pi over 4, because already we know that tangent pi over 4 is equal to 1. So that means pi over 4 is equal to tangent inverse of 1. So at the place of -1, if I have positive 1, then this is equal to the angle measure pi over 4 in the first quadrant. But here it's not a positive one. So what do we have? We have -1. So, we can have an angle measure in the second quadrant, because in the second quadrant, the tangent is negative according to the concept AS TC. So in the first quadrant, all trigonometric ratios are positive. In the second quadrant, only sine and its reciprocal cosecant are positive, the rest are negative. So the tangent also must be negative. Here it's negative. And already we got the angle measure when the tangent value is equal to 1, that is pi over 4 in the first quadrant. That pi over 4 should be used as a reference angle in the second quadrant. So when we have pi over 4 in the first quadrant over here, we got the value of tangent as 1, but we don't get 1 as a value of tangent, we get -1. So whatever angle measure we are getting for tangent inverse of 1, so that angle measure pi over 4 should be taken as reference angle in the second quadrant. So we go to the second quadrant, because in the second quadrant tangent is negative, here we have negative value. So this is pi over 4 over here, sorry, not pi over 4 over here. So the reference angle is pi over 4. So to get the angle measure over here, we have to subtract this pi over 4 from this pi. So pi negative pi over 4. So when I simplify this one, I am getting 3 pi over 4 for this tangent inverse of -1. So 1 over 4 times x negative pi over 2 is equal to 3 pi over 4. Okay, so to get this 1 over 4, I have to multiply both sides by 4. When I do so, so this 4 will cancel out, here 4 will cancel out. I am getting x negative pi over 2 is equal to 3 pi. Okay, now let's add pi over 2 to both sides. So this negative pi over 2, positive pi over 2 will cancel out. I'm getting x equals to 3 pi positive pi over 2. So to simplify this one, let's multiply this denominator and this 3 pi. I'm getting 6 pi. So once I'm done with this multiplication, I can take this 2 as a common denominator. I get x equals to 7 pi over 2. So I got one of the x-intercepts. We have multiple x-intercepts because we have multiple patterns. So here, this pattern, this particular pattern intersects x-axis over here. In the same way, there will be other patterns to the right side and also the left side as well. So but anyway, one of the x-intercept is 7 pi over 2. So how do you have to get the other x-intercepts? To get the other x-intercept, for example, if I want to get the next x-intercept to the right of 7 pi over 2, I have to add 4 pi to this one, because 4 pi is a period. So in case if I want to get the x-intercept to the left side of the 7 pi over 2, I have to subtract 4 pi from this one. So in general, we'll be writing 7 pi over 2 positive 4n pi. So when I plug in n is equal to 0, it will become 0. Then we get one of the x-intercepts as 7 pi over 2. If I plug in n is equal to -1, I'll be getting 7 pi over 2 negative 4 pi. So this is the x-intercept, the first x-intercept to the left of this 7 pi over 2. If I take n is equal to 1, so 4 times 1 times 5 will become 4 pi. I'm just getting 4 pi. So when I add 4 pi to this one, I'll be getting the x-intercept to the right of this one. So to get all x-intercepts, what we need to do is we have to add a multiple of 4 pi to this one, because 4 pi is a period. So these are the x coordinates of the x-intercepts. Already we know that y coordinate is 0.